2x plus 3y, everything squared. And let's say I write 4x squared plus 12xy and plus 9y squared. And if somebody's asking me, I don't understand why it's 12xy, I'm going to pull this and say, we signed an agreement. No cell phones, no music, nothing. We just have to pay attention. Please, please. Okay? So let's start with this. And the first thing I'm going to ask is how do we call this? This is something for the notebook. Terminology. This is what I did today. This is what I learned today. New things that I need to remember. Something that I have to look at, blah, 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 blah. Okay. So what is a plus b? Or a minus b? Or 2x minus 3y? Or x plus y? Or, you got the picture. What are they? What is the name of all these? Say it again. Awesome. Perfect. They are binomials. So a binomial is an addition or subtraction of what? Equals addition or subtraction of, this is very important, this is again terminology. How do we call these two? A or B, 2x, 3y, how are they called? Again, this is a key word, a key concept. How are these called? How is this called? So binomials are addition or subtraction of two, please. Terms. When we add quantities, they are called terms. If we add 2, it's a binomial. We are adding or subtracting 2 terms, a binomial. When it's 3, it's called a... Excellent. Thank you. Good. What about this? What is this and what is that? How are they called? They are not added. They're not subtracted. So they cannot be terms. They are multiplied. So how are they called when 2 quantities or more are multiplied? Don't be afraid to be wrong. Give it a shot. Thank you. Very important. These are very important keywords. Now I can say moving forward, we prefer factors. That's why all this theory behind factoring. We prefer factors. Factors have more applications than terms. Good, very good. So then right here, all we want to do is square. What are we squaring? A binomial. We are squaring 2 terms or we are squaring a binomial. Awesome. Now, for now, today, just for once and the last time, we are going to FOIL this, but not anymore. You can say, but am I wrong if I FOIL? No. Will I get full credit if I FOIL? Yes. Should I FOIL? No, because we are going backwards. If we try to move forward, we should be able to square a binomial and get the result without foiling it. Why? I'll explain why. If I understand the formula and I'm able to apply it this way, I will be able to apply it this way when I have to factor. Otherwise, I will always have a difficulty when factoring a trinomial. Okay, so let's FOIL it right now. A plus b times a plus b. And when I FOIL, when I multiply 2 binomials, how do I do this? Well, a times a is a squared plus So a times a is a squared, then a times b, good, plus b times a, and times b plus b times b. Good. What do you notice? That you can combine like terms that's another keyword, or keywords if you want, combine like terms. And what happens here is you get a squared plus 2ab plus b squared. Agreed? So then on your form, not the one you gave me, you will give me, that I don't need it, you will write a squared plus 2ab plus b squared. Now, two things I would like you to pay attention to. First of all, we understand this, everyone? Yes? Okay, perfect. So here's what I want you to tell me. A binomial, is this a binomial? Okay, a binomial squared is a, what is this? Very good. So this is a key concept that I would put in my tiny little notebook that I would look at before I fall asleep, or before I come to class, or every weekend, or whatever. Okay? A binomial squared is a trinomial. What if I cube a binomial? What if I have a binomial raised to the third power? How many terms do you think I will get? Exactly. One more than the power. Very good. One more than the power. Very good. So now let me tell you how I remember this, that I strongly encourage you to do. So this is a term, correct? I'm going to call it the first term. Plus, this is, what do you think? Of course. And I square it. So what do I get? I get the, awesome, plus 2 times first term times plus, on your way to where you're going tonight, hopefully you're going home, you should say first term plus second term squared equals first term squared plus 2 times the first times the second plus the second term squared. 10 times. And you will not forget this. Because it's not useful to FOIL. You have to FOIL when the two binomials are not the same. You have no choice. So if I have 2x plus y times x minus 3y, you have to FOIL. But not on 2x plus y squared. You shouldn't. You should move away from that. So what is the answer? For 2x plus y, everything squared. First term squared. What is it? Yes, but I want the answer. I have to square 2 plus. Now I have to multiply the two terms, 2y times y, 2x times y times the 2 outside. How much is 2x times y? 2xy times 2. That's it. Plus the second term squared. That's it. Why? Because we understood the pattern. The first term squared plus 2 times the first times the second plus the second term squared. Let's try another. Give me another example of something you want to square. Oh, I'm sorry. Did I cover it? So give me another example, please. Okay, 5x plus 2y squared. First term squared. 25 x squared plus. Multiply the two terms and multiply by 2. So please multiply 5x by 2y squared. 10xy squared multiplied by 2. 20xy squared plus the second term squared. Very good. So this is what I would like you to practice. But first things you have to remember is the pattern. First term plus second term, everything squared. First term squared plus twice times the first times the second plus the second term squared. You can do this. Okay, what about the second one? What do you think is different with the second one? Exactly. So what will be different? Which one? Excellent. Which one? There are two addition signs. Which one? Exactly. A squared minus 2ab plus b squared. Awesome. Give me an example, please. Make one up.
1x minus 3y.
Awesome. Awesome. Let's say 4x squared this time and 3y to the third. Awesome. Thank you. Remember the pattern. First term squared. What do I get? X to the. Awesome. Sign now. What is the sign? Awesome. Multiply the two terms and then at the end multiply by 2. So please multiply these two terms. 12x squared y cubed multiplied by 2. That's it. 24x squared y cubed plus the second term squared. Nine y to the. Copy the base. Multiply the exponents. Multiply 2, 3 times 2 is 6. Very good. Any questions? Okay, last one. These are all 3 commitments. Just a little game we're trying to play so then we can move away from this. And I'd have to come back and do it again and again. Okay, last one. What do you think? You can foil it now and give me the answer. But never again. We're done with foiling. Unless we have no choice. What is the answer for the third one? Very good. Very important. Difference of squares. You see it on my handout on factoring. All of these. You recognize this? You recognize this? You recognize this? Okay, so they're all examples on factoring. Good. So let's make one up. Anyone?
Do 2x plus 4y, and then 3x, or then 2x minus 4y.
Aha! I wanted to catch you. Thank you. Good. The first term squared, please. Minus. It's a difference of squares. The second term squared, please. Awesome. So I'm really hoping that you will practice these 3 and whenever we write, like coming back to this, you're not going to say, it's okay if you're saying it, but I'm going to say this. We have an agreement. So if you say, I don't understand this 12, where does the 12 come from? Where does the 12 come from? Can anyone explain where does the 12 come from? Multiplying these two.
And then multiply by 2.
That's it. Awesome. Very good. So I'm going to take this at the end of the class. Just your signature that you agree with working on this and practicing and putting it away. Okay. Now, I like to start with 1.1, which is, I know I only have 15 minutes left. 1.1, linear equations, graphs, and so on and so forth. And I am trying to stick within, I no longer have that, or I do. I put it away. It disappeared. That's fine. So, but I gave you is the handout that I don't have enough for. Okay. On page, we start with page 102. I like to look at a couple of functions. And let's start with y equals -1/2 x. Okay, so what is this? Yes, it is a slope. What is a slope in here? The negative, the -1/2 is the number in front of x. That is a slope. No, but I was asking, what is this? What type of equation is it? Or function. I can also write this. And how do I know? It is linear indeed. Linear equation or function. Very good. Perfect. How do I know it's linear?
Because it's a straight line over that.
That's true. But how do I know you're right? The powers of the variables x and y are 1. So power 1 and 1. 1 for y and 1 for x. That's the first condition. Second condition, no variables in the denominator. Something over x is not linear. So y equals 1 over x. This is not a linear equation. Not linear. Also, if we have products of variables, so xy equals 10, not linear. Okay, so this is indeed linear. We're asked to graph this equation. We know it's going to be what type of graph? Yes, that's the simplest possible function, simplest possible equation. The graph will be a straight line. Perfect. So every time we graph a function or an equation, we always look for the x and y intercepts. X intercept, bless you, y intercept. Always, if they exist. They may not exist, but we always look for them. Okay, so let's look at the following graph for a moment. So this is a function, f of x. Does this function have x intercepts?
Yes.
One here and one here. So these are the x intercepts. Correct? So this is the x-axis. What is the equation of the x-axis? Altitude what? The x-axis has what altitude?
0.
Exactly. So what variable measures the altitude?
4.
So what is the equation of the x-axis then?
0.
4.
X. 0.
So we're talking about altitude.
Or y equals 0.
Correct. Y equals 0 is the equation of the x-axis. Y equals 0 represents the x-axis. Now what about this function? Does it have a y-intercept?
Yes.
Right here. Y-intercept. Good. So what is the equation of the y-axis?
X equals 0.
Awesome. The equation of the y-axis is x equals 0. So now I know what to do when I'm asked or when I want to determine the x-intercept for this function and then the y-intercept for this function. So how do I determine the x-intercept again? So I have y equals negative 1/2 x. How do I determine the x-intercept again? I make the x-intercept. I make y equals? Perfect. So the equation becomes 0 equals negative 1/2 times x. Negative 1/2 times equals 0. Times what? Negative 1/2 multiplied by blah is 0. What could it be? Of course. So what is the ordered pair that we just determined?
0, 0.
Perfect. Since this is the x-intercept and the y-intercept, I was looking for the x-intercept, and then the y-intercept is the same, and the x-intercept is the same, I have to create another point. And I would like to say 5, 9. No, I can't do that. I have to pick the x and determine the y, or I pick the y and determine the x. I can't say, okay, I'm taking from this pocket x and from this pocket y, and that's 5, 9. No, it doesn't work that way. So let's choose an x. Choose a y's x. If you say 9, then I will have to determine a number for what? If you say x equals 9, then I have to determine a y value. Will be a little bit more difficult to plot, but not impossible.
1.
1 is not a good idea for the same reason.
So 4.
2 or 4, or negative 2 or negative 4. Which one would you prefer?
2.
Good. So then how much is y?
-1.
Yes, because you have to plug it in. So negative 1/2 times 2/1, you simplify. Please remember, we write the ones, not to assume that it's 0 or something. So it's negative 1. So what is the ordered pair that we just determined?
2.
2, negative 1. There is no 0. We made the x 2, and we determined the corresponding y. So it's 2, negative y, negative 1. Are we in agreement? Any questions? Please ask. I will not know if you have any questions if you don't ask, right? Okay, so we are ready now to plot those points, connect them, and extend the line. So the first ordered pair that I have to plot is
0, 0.
awesome. And the other one is 2, negative 1, right here. 2 for x, negative 1 for y. I connect and extend the line. I missed it a little bit, I'm sorry. Always write the name of the line or the graph somewhere. Y equals negative 1/2 x. Very good. Any questions? Any questions? Remember the x and y intercepts. I'd like to look at problem 24 on the same page, 102. So y equals the absolute value of x minus 1. Before we do that, I'd like to come back here for a moment and ask you, what is the domain of this function? What is the domain? Awesome. How do I know that the domain of this function is negative infinity to infinity? How do I know? The question on the domain is really a question of what values I can plug in or what I can replace x by that makes sense, and I will always get a y back. So in this expression, negative 1/2 times x, I can plug in anything I want. I can replace x by whatever, and I will multiply by negative 1/2, and I will get an answer for y. That's the reason why the domain is all real numbers. What about the range of this function? What about the range of this function? How do I determine the range? What does the range mean? It's the same question, but not for x, but for y. So the x values go from leftmost x till the rightmost x. The question on the range go from the lowest y till the largest y. What will you say about the range of this function then? Of course, the same thing. It goes everywhere. So from a negative infinity to positive infinity. Awesome. So now we're ready for this. I'm going to ask the same question. What is the domain for this? Again, the same idea. What can I plug in x? And by the way, what type of function is it? Of course, it has an absolute value. Thank you. Equation or function? Awesome. So now I'm asking, what is the domain of this? The question is, can I plug in anything I want in x? Can I determine the absolute value of negative 10? So what is the absolute value of negative 10? 10 is the distance from 0 to negative 10. Can I plug in 0? What is the distance between 0 and 0? 0. Can I plug in 5? So what will be the domain? Anything. Friendly function, I call it friendly. I recommend a horizontal chart, not a vertical chart, only because x is on the x-axis. If you prefer a vertical chart, go ahead and use a vertical chart. I'm fine. I was going to say that all I want you to do is compare my method to another method that you know or another method that you read about in the book. And then after you compare them, you can still say, I still prefer the book's method or the method I knew from before. I'm fine. But sometimes you may say, I think that her method is better or easier. But I'm fine if you stick with the method you know. Okay? I'm not trying to reinvent the wheel here. Okay, so you said all real numbers. So let's plug in some numbers for x. And let's say negative 3, negative 2, negative 1, 0, 1, and 2. So let's determine the y values. So let's plug in negative 3. What is the absolute value of negative 3? Minus 1. That's it. Let's plug in negative 2. The absolute value of negative 2. Minus 1. Perfect. Let's plug in negative 1. Minus 1. Perfect. Let's plug in 0. Minus 1. Awesome. Let's plug in 1. Good. Let's plug in 2. So let's graph the function. From left to right, please read the first ordered pair you would like me to plot. Yes. From left to right. We read and we do everything from left to right. Very good. 1, 2, 3, 1, 2. Next one. Very good. Awesome. Next one. Awesome. Next one.
0, comma, 1,
Perfect.
then 1, comma, 0, then 2, comma, 1.
Remember, the absolute value function is like a V. It can be an upside down V, or it can be up, going up V. Okay? Can anyone give us the range of this function? Yes, any questions? Any questions for me? Any questions? Can anyone give us the range of this function? Remember, from the lowest y value till the largest y value. Yes?
Would it be -1?
Perfect. Now symbols. Left here and right. What symbols do I use?
You're going to use the square, like the half.
The bracket, very good, because the point exists. Awesome. And the infinities are always, we say, open. Parenthesis. Very good. Excellent. So from 1.2, I would like to illustrate with a linear equation, and then we can stop. Let's say problem 14 on page 120. So this is 1.2. And we have 5x minus quantity 2x plus 2 equals x plus quantity 3x minus 5. I will not hold you over. I only have 2 minutes, and then I'll stop. Okay, what type of equation is this? No variables in the denominator, no product of variables, and the variable has power 1. What can it be? Awesome. So this is again for your notebook of terminology and important information to remember the fact that when the power of x is 1, it's linear. No variables in the denominator, and so on and so forth. No square roots, and so on. Okay, now on the left-hand side, I want to remove parentheses. So I have 5x, and then I write minus 2x. Very good. Good. Here I have positive 1, so I can drop the parentheses. In the next step, I have to combine like terms. So when I combine like terms on the left, I get minus 2, and on the right? Good. Here's what I recommend, and we can talk in details about it on Thursday. When you move a term from, you have to keep x on, shouldn't say have to, but most of the time we'll keep x on the left-hand side and everything without x on the other side. This is linear. If it's something else, we're not going to do that. But since it's linear, I want to move this here and this here. I know you're used to writing minus, minus, plus, plus, whatever. You can do that. I recommend this method. When I move 4x to this side, I have 3x minus 4x. That's all it happens. When I move a term from one side to the other, it changes its sign. It was positive, it becomes negative here. 3x minus 4x is negative x. When I move this term that was negative from one side to the other, it becomes positive. So negative 5 but plus 2 equals negative 3. Final step, x equals 3. This is the method I recommend.